Here we have some data from 4 elephant seals. Each seal wore a sensor that recorded daily measurements for about 200 days. Included in those measurements were the animal's location. See the latitude and longitude columns here? This information allows us to make a map, which is done using the Map button here. Each dot represents one of the daily measurements for an elephant seal. You can use the plus and minus buttons to zoom in or out, or you can double-click to zoom in and shift double-click to zoom out. Grabbing any part of the map that doesn't have a data point allows you to drag the map to reposition it. One interesting feature of location-based data is identifying areas where lots of data has been collected. In this case, it shows where animals spend more of their time. One way to help identify these areas is to use the grid tool found in the Values Inspector. The redness of the block indicates the number of measurements. We can hide the points to focus more on these active regions, and we can refine the areas by adjusting the grid size. As with all representations in CODAP, map views are linked with all other data representations. We might use a graph showing curviness measurements to see if swimming patterns correlate with certain areas in the map, as we can see here. If we wanted to see where the animals were on any particular month, we could grab that attribute from the table and drop it on the map. Here we see that the animals show a lot of curvy swimming behavior in September and August, but not so much in July. Dropping Animal ID on the map allows us to see which data points belong to which animal. CODAP can also create maps that have geographic boundaries. Here we have state-level data, which can be visualized by dropping those attributes on the map. For example, we can look at average educational attainment or total population.